IR spectroscopy. For a carboxylic acid, carboxylic acid has a double O bond to it, and then it has an OH bond to it. But the thing is, there is the C double O bond is at 1700 centimeters. The OH stretch is from 2500 to 3300 centimeters, and that's for carboxylic acid. For alcohol, which has the OH, it has a stretch at 3200 to 3600. For aldehyde, which has a double O bond and an H, the C double O bond happens at 1700, and there is a signal from a CH that happens at 2900, and there's one that happens at 2700. That's for aldehyde. For ketone, it only happens at 1700. For ester bond, an ester bond has an sp2 and an sp3 bond on it. Alright, and it happens at 1700, and at the CO bond, it happens at 1200 to 1300 cm, and one at 1000 to 1150 cm. For ether bond, which has a bond and an O, then a bond, and this is an sp3, the signal will happen, the CO signal will happen from 1000 to 1150 cm. So there's a distance between the ester and the ether bond. The ester has a sp2 and a sp3. It has resonance. The ester bond has a signal at 1700, a signal at 1200 and 1300, and a signal at 1000 and 1150. Now, ether bond has an sp3. Like I said, it is the bond, it has an O and a bond. The CO stretch will happen from 1000 to 1150. For amine, which is an NH2, is a primary. The signal will happen at 3300 to 3500, or it will happen from 3300 to 3500. Now, amide, which has the double O bond and an NH2 bond to it, it has a signal at 1700, as well as it has a signal at 3300 to 3500. Now for alkane, this is sp3. It has a methyl group. The signal happens at 2900, and then there will be something, a CH bend that is at 1365 to 1385, and a CH stretch from 1400 to 1450. For alkene, you have a double bond, and there will be a signal at 1660 centimeters, and then there will be another bond from 3000 to 3100. For alkyne, this will be a triple bond, and you will have a signal from 2100 to 2200 cm, and this will have an sp hybridization, and you will have a CH stretch from 3300 cm. Now the stretches, if the S increases, the wave number also increases. For atomic mass, if the atomic mass increases, the wavelength decreases. So for a CH bond, that's 2900. For a CO bond is 2100. A CC bond, that's 1000 to 120 200. For C to Cl, that's 600, 800. C to Br, that's 500 to 600. As the atomic mass increases, the wavelength goes down. As the bond strength increases, the wavelength also increases. So the highest bond strength is the triple bond, and the smallest is the single bond. All right. So the triple bond has 2200, the double bond has 1650, and the single bond has 1000 to 1200. More energy is required to stretch a triple bond compared to a single bond. A conjugated ketone absorbs higher energy at a lower wavelength number. A conjugated ketone has a bond in a ketone, a double bond in a ketone. The double bond happens at 1600, and the ketone happens at 1680. A non-conjugated, so a conjugated one has the bond close to the ketone. A non-conjugated one has the double bond furthest away from the ketone, and that double bond is still at 1600, and the ketone is at 1720. And conjugation can reduce wavelength. The one with the most double bond character is the one that has the double bond furthest away from the ketone. The one that has the most single bond character is when it has the double bond close to the ketone.